Good afternoon, everybody. And thank you very much for Tatsushimi-san to invite me today to speak, as well as I really appreciate the executive from IPA to organize this event and allow me to speak here today. It's an honor that I can be here and talking to you. And thank you very much all for coming today. I want to talk about today a little bit about the future directions of ICT in the human resource area, the development globally. And I'm also going to talk a bit more about in the computer society, in IEEE Computer Society, what are we doing about all the activities that we do, some of the research that we've done, as well as my involvement with other organizations around the world. To start with that, I would like to introduce myself to you. So my name is Andy Chen, and I am a CEO and president of my own company. I have a consulting firm. I consult around the world on, more importantly, electrical powers, energies, computer technologies. And I'm a senior business advisor to several leading global firms around the world, which I frequently traveled. And I was the chief technology officer and the vice president for a large utility company in Canada, where I worked for 30 years. And I speak internationally about different conferences, including I just finished a speech in Africa, Nigeria, Africa, about digital Africa. And I was the keynote speaker for World Computer Congress 2015 in Korea and World CIO Forum in Xi'an, China. I'm also board of governors and the members of IEEE Computer Societies. As well, I'm on the board of directors for the organization called Federations of Enterprise Architecture Organization, short for FEOPL. And I will go through some of these details with you today. A little bit about what I know and from our studies. And in Ireland, there is a global research firm funded by the Irish government. They do a very comprehensive studies, and one of their conclusions, prediction, is that there will be close to 45,000 new jobs in ICT skills. But it is in the high end of the ICT skill, meaning that it's for experts, experience, not for the entry levels. As well, the country where I came from, in Canada, we have Information and Communication Technologies Research Councils, and they also did a comprehensive studies. And in Canada alone, the company is predicting that almost over 100,000 new jobs will be created in the ICT area. So in ICT, this is a good time. A lot of people worry about their jobs, but the good news is there's a lot of new, exciting ICT jobs available around the world. But there is the bad news goes with it as well. The bad news is that it is predicted that 1 out of 3 ICT jobs today, it will be decreased by 80%. So 8 out of 10 people that work in ICT would not be working on the job they're working today over the next 6 years. So what they're saying is that 80% of those jobs, it's going to be either done by somebody else who's less skills, entry level, because they automated so simple, or they automated completely and be done by the machines. Now, so the trick is, how do you know which job? what jobs going to be there, what jobs not going to be there in the future. You need to at least have some ideas. The good news is there is a research and a website that actually do the predictions for all jobs in all sectors of the industries, not just computers, manufacturers, automobiles, every industries. And in that website, it says that this is just filtered out in the computer-related area, that almost half of the people who does computer programming today, they won't be doing it in 6 years from now, because it's been replaced by language auto generations and more powerful language tools that you would no longer be required for detailed computer programming. On the other spectrums, if you were doing computer system analytical work as an analyst, chance of your job getting replaced by machines are very small, like 0.6%. And if you were doing the database, very high big data areas, again, it's a very stable area where most jobs will remain almost the same as today. The trick here is, what this site doesn't tell you is, what are the jobs that's coming down the road? What are the new jobs that are actually going to be created that's not even today? That is going to become something that ICT profession want to consider. So just for example, question is that, what are new jobs? And one example I'm going to give you is what I get involved in what I call the enterprise architectures. And I'm just going to go over a little bit more because that's an area where I think it's emerging and it is going to be become relevant in the future. So the question is, what is an enterprise architecture? It's a good question. What I'd like to share with you today is give you an analogy, because most of us would know what an architecture is, what can architect do, and what an architecture is. If you think of a building on the left-hand side, where building architecture, or the architect themselves, they will focus on one single building. And they were concerned about the needs of the people who live in that building. And what they worry about has to do with how you make the building owners happy, solving his problems. So that's what the building architect is. What is an urban planner? Urban planner is another word like a city architecture, somebody who does architect for the cities. And the urban planner that worry about it is the whole cities. What they worry about is the flow of services, like the traffic, the rush hours, the utilities, and the quality of people's life, how to make it easier every day, make it more convenient for you. And what they worry about is the future of the cities. And a lot of people talk about smart cities, and that's actually one of my topics that I was delivered in Africa. It's the smart city of the futures. Now, with that analogy, you think about what is a solution architect. Solution architect, most of you would know, is an IT architect. They build a system, and you need some architecture to make sure that everything hangs together. So a solution architect, they focus on single system or single process. They're concerned without meeting a specific need of that systems. And they worry about the system owners' concerns. They make sure the system owners, the owner of the systems, are happy. Whereas the enterprise architecture, or the architect themselves, they focus on the entire enterprise. Now, they're concerned with the value of the organizations. How do you increase the value of organizations? And how do you improve the process and the information flow? And all the ongoing activity within the enterprise. So the solution architect and enterprise architect is similar to what building architect to a city architect is. It is said that enterprise architecture is now a strategic component of every forward-thinking company in the world. So the company like Microsoft, Intel, every company that forward-thinking, they will put in an enterprise architecture component in their organizations. And for example, in the United States, if you are a company, you want to bid a contract with the government agencies, especially in defense, you would require to demonstrate that your company has a setup on the enterprise architecture disciplines. So it started making it relevant to a lot of people. In a technical terms, an enterprise architecture is actually a combination of the business architectures, application architectures, data architectures, and infrastructure architectures. And you collaborate between all these different architectures, and you start building automation between the different architectures, and you use these to enable the business, the whole company, not just one specific area of your company. There is a very popular book called EA Good Practice Guide, and this is the quote that I directly get it out of from. The FIPO organization, which I belong to, has close to 20 members, and these are just samples of the members' organizations. Each organization could be 40,000 people, 100,000 people, combined together as a federations. IEEE is one of them. British Computer Society is another one of them, and Canadian Information Processing Society is another one of them. So you can see the list of different big organizations get together. Right now, the membership of the FIPO organization reach out to over 1 million ICT professions in the world. And I am representing IEEE Computer Societies in these FIPO organizations. So what does it do? What it's trying to do is trying to bring all different large organizations together for best practices, to collaborate, to work together, and to define what is the enterprise architectures and how do you help the people advance in the enterprise architecture. There's a website on the bottom where you can look up more information about FIPO.org. One of the things that's very important in everybody's mind is once I get a job, how do I grow my career? How do I move my career path to promote, to be a higher level? How do I become a vice president or president of the company? And we work together at these things called the Career Path Guide. And I'm going to tell you a little bit more about that. We did a quick survey on people about if we would write such a guide for career path for people who wanted to get into the enterprise architecture, want to become relevant and become excel in their company, what kind of skill do they need? The survey come back saying that all the people who took the part on it, 20% of them want to understand what do you need to be successful in EA career, in enterprise art career. And 14% of them want to know what kind of skill do I need to jump from a solution architect or a business architect into an enterprise architect. And 40% of them want to know, how do I manage my career? How do I make my career excel? And 10% of them is interested in education product. What kind of courses do I take? What kind of training do I need? What kind of certification do I need? The scope of the career path is just a parcel of different area you need for professions. For a profession, you need a job family and roles, you need the competency models, and you need the career path. And those are foundations that to the beginning of the academia training. In academia training, in the training area, you need body of knowledge, you need curriculum, you need accreditation criteria, you need preparatory educations, skill development, and continuing educations. So, for you wanted to know more about FIPO, please look up FIPO.org. I'm going to move into Computer Society and let you talk about what Computer Society is actually doing now. I'm going to play a quick video, and it's in English, so I will inject some highlight for you and translate it.
Innovation, inspiration, collaboration. The IEEE Computer Society, celebrating 70 years as the computing profession's single, unmatched resource for a global community of technology leaders.
So we are 70 years
Z3,
in the making.
Colossus, Adanasoff Berry, UNIVAC. The war has
1940.
ended. The computer age has begun.
When the
In
computer age
1946,
started,
the industry transitions from electromechanical to electronic circuits, and the American Institute of Electrical Engineers creates the Subcommittee on Large-Scale Computing. The Institute of Radio Engineers follows suit in 1951 and establishes the professional
1950
group on
is when we start
electronic
getting into the
computers.
computer and
With conferences
computer-related
and publications
area.
that explore a new world of microprogramming, compilers, and development languages, these two organizations grew significantly in the 1950s. IEEE Transactions on Computers, IEEE's longest-running journal, is established. ASCII, BASIC,
In
the
1960,
mouse,
we started looking
ARPANET,
into more in the
Apollo.
hardware aspect of
In
the computers and the
1963,
standards.
AIEE and IRE merged to form the Institute of Electrical and Electronics Engineers, joining their computing committees into the Computer Group. In 1966, the bi-monthly Computer Group News is launched, offering group news, applied and tutorial articles, and a repository of computer articles. Full-time staff is hired in California to manage publications. The Computer Society is the first society to employ its own staff.
So Computer Society is the
Unix,
first society
the
in IEEE
microprocessor,
as well as
electronic
the
mail.
largest.
The Computer Group is renamed the IEEE Computer Society in 1971, and the 1970s brings tremendous growth. The Education Committee produces the first model curriculum.
In
and the
1970,
society
we started
establishes
the
first
education
student branch
aspect
chapter
of the
within
computer
IEEE.
engineering.
In 1977, the IEEE 754 Floating Point Working Group begins formulating groundbreaking arithmetic standards for computer microprocessors. The IEEE Transactions on Software Engineering and IEEE Transactions on PAMI are introduced.
So we started
Personal
focusing on
computers,
software engineering in computer society.
CD-ROM, NSFNet, mobile phones. The PC revolution welcomes computers into the home. And as the industry diversifies into these new markets, so does the society, adding 15 new technical committees and 6 periodicals by the end of the decade.
So in
Computer
1980,
hardware
we
and
really grew a
software
lot.
engineering
We have
standards
15 more
development
technical
increases in a
committees that was
major way.
formed.
Offices in Los Alamitos and Washington, D.C. are expanded as the Society establishes IEEE's first international offices in Brussels and Tokyo.
So
Members
Tokyo
begin
is one of our
receiving
first
email addresses
society
as a
office
benefit of membership.
in Asia or in the world.
The World Wide Web, Mosaic, Java, Deep Blue.
In 1990, we
Wi-Fi.
started to work on
As
some of the
World
key
Wide Web
standards.
explodes across the globe.
IEEE
The Society
802.11,
opens
the
centers in
hotspot,
Budapest,
wireless
Moscow, and
is
Beijing,
one of our
and sees a
standards that
rapid
we
growth
issue and
of
support.
Conferences and publications. 1997 brings the Computer Society Digital Library online, and IEEE 802.11, the revolutionary wireless Internet protocol, becomes an international standard. Smartphones, 3G, Blu-ray, the cloud, Roadrunner. At the turn of the century, game-changing mobile products help make computers an integral part of our daily lives. the first software engineering body of knowledge is published. The society establishes
The software
professional
engineering body of
certification
knowledge
standards
was introduced
and
in
a professional
1980s.
education program and launches its first online-only magazine. Petaflops, tablets, HTML5, wearables, quantum computing. The computing field continues to rapidly evolve, with social media reshaping the way we interact and the cloud streamlining on-demand access. The Computer Society launches Computing Now, a portal for publications articles and multimedia content, and creates the user-driven content delivery system, My Computer. Rockstar events and Tech Ignite
We also
provide
do conferences
industry-oriented
around the
content.
world.
The
Large
Society
set of
leads
conferences,
the IEEE
over 1,000
cloud
conferences.
computing, cybersecurity, and rebooting computing initiatives to pave the way for future innovation in the industry. A new tiered membership program launches. For 70 years, we have been at the leading edge of technological advancements that have reshaped
So we've been
our
around
society
for 70
in profound
years
ways.
as
We are the
IEEE
trusted
and
source for
Computer
technology,
Societies.
information, inspiration, and collaboration. We are the leaders of the technological revolution. We are the IEEE Computer Society.
So let's give you an idea about what we do now. What I want to do now is taking through each of the area and expand a little bit more about giving more information on each of the area that in the video itself. So, what is the ICT challenging today? Why is ICT facing such a challenge in the market and are such dynamic challenge area? First of all, ICT is not really a recognized professions. It's not like an engineer where people will go through engineering studies, certified, license, become an engineer, or a plumber, or a doctor, that they are professions. So there's no common definitions of what ICT profession is. So you don't know who's good or who's bad because there is no certification or nothing really to compare globally. And there is no common framework for what an enterprise IT should look like and should be, the attribute need to be. And there is no standard competency measuring models. And that's where some of the stuff worked right here with IPA is so important. They are addressing the third part of the equations, trying to standardize it, trying to provide more clarity on the competencies by developing the competency dictionaries. For the employer, there is no reliable university they can go to find an ICT professions because it varies from different school to school. And the experience that they have from one organization is not usually transferable to the other organization because there's no standards to transfer or references. And it's very difficult for people to actually grow in the area. And I mean, I always say that wouldn't it be nice one day if you get a job or you get a promotion because of what you know, your competency is who you know, right? A lot of promotions are done by who you know. You've got the right network connection, you do that. But if there is a standard way of evaluate who's better than who, then you can actually be able to prove it yourself without knowing any connections. So I want to go a little bit more deep into detail about what are professions and what does profession need. Profession need to start with educations. Education, education, education. So you need to educate the people. That's where human resources is, right? Educate the human resources. Everything started with the body of knowledge. With the body of knowledge is a collection of the knowledge from the experts into one big depository information where people can draw information from. And it's what we do in Computer Society, and I'll explain that a little bit more. From body of knowledge, you can start to develop curriculum. Curriculum for university, curriculum for graduate school, curriculum for colleges. You need a reference to build it. So body of knowledge gives you the reference. And you need to have people actually check on those universities, do the accreditations, to make sure those universities actually follow the curriculums and body of knowledge that is transcribed by the professions. Then you need to recognize different degrees for different level of difficulties. And after that, you need to be able to demonstrate that you are certified to do certain things by testings. And last but not least, you have to be able to build licensing. License allow you to practice. License allow you to recognize as professions. So that is the training side. When you get into the workforce, you need to know what profession, you need to know what a code of ethics is. And every profession has their code of ethics and the standards for that profession itself. And you need to understand what kind of job role is there for that discipline, for that professions. And career path, which what we're trying to develop, you need to have that career path to know how one can go from one role to different roles and with what kind of competencies and skills that's required. So this is a, excuse me, this is a very high level of a profession. And in IEEE, we developed a white paper to describe each and every one of these components. And I will refer to that to you in a minute. IEEE, we have about 400 members across the 160 countries. Those are mainly regions. Region A, Region 10, Region 7, Region 1, Region 9. Different region is how we divide it into our local chapters. And for Computer Society, we found out that R8 and R10 today is the fastest growing chapters in our membership. R8 is Russia and India. R10 is Asia, Japan, China, Taiwan, and South Asia. And R10 by far is the fastest growing in all of our rest area. Last year, they came in very high increases compared to all other chapters in the world. Like I say, Computer Society is truly global. We are present around the world. Every country in the world, we have different chapters. We have different scholars, industries that are working with us. We have a total of 550 chapters. We issued about 160 standards, part of our work. IEEE has 43 sister societies. Computer Society is the first society as well as the largest societies, and we have Communication Society, Power Engineering Societies, and so forth. We have 28 technical committees. They focus on different topics, like Internet of Things, large core scale computing. But more importantly, we have 14 special technical communities. I'd like to bring attention to those 14 special technical communities because everybody here can join those communities. You don't have to be an IEEE member. You just have to be interested in the topic. And we're trying to encourage everybody to participate in the communities, almost like a special interest group. We publish about 30% of the world publication relevant to the technical area that we're in. 1 second. It gets pretty dry here. For the 14 technical communities that I mentioned about, I just threw up here so you know there's different area like cloud computing, cybersecurity, education itself, electronic, government, all different type of specialty area there. If that's what you're interested, you can actually just sign up to be part of those communities. I am the chair of Enterprise Architecture Special Technical Community, as well as System Engineering Technical Committees. So we welcome all your participations. Anybody who would like to be part of these, we're more than welcome. I'd like to talk a little bit more about professional education and training, which is what I'm responsible for. I'm responsible for all the professional education and training globally for IEEE Computer Society. So every part of the world, I've been speaking in different area, trying to get more exposure to what we do, looking for partners, looking for organizations to work with us. We have one of the largest e-learning libraries. We have hundreds of online courses, and they are free to our members. We have 600 online books that is, again, free to our members. And we certify our member for different level, associate level, beginner levels, professional level, mid-career level, or master's level certifications. And we also provide training to the organizations we call train the trainers. We go to the company and train the people that's going to train everybody else within the company. And we also do one-on-one to a different organization, provide customized training. We did such things for Intel. Intel was very interesting in quality engineering of their product. We provide customer training for their quality engineers to certify them, to make sure that they are, in fact, up to par on not their knowledge, but their skills and their competencies. And we also offer, like I say, online, many online course certifications. We have a catalog, which I can share with you. More importantly, we're working with the industries to actually get these, all these out there. This is the model of IT professions, and there is a white paper that we wrote that actually go through each and every of these artifacts, code of ethics, standard practice, and the activity you have to do in the professions, job role, career path, and also a society, something that all the professionals get together and develop what the profession needs. Standards, and more importantly, competency definitions. Again, on the educational side, you have body of knowledge, curriculum, accreditations, and the degree program where you prepare people into different degrees on the preparatory educations, and the skills, different skills development, and ongoing educations. In many professions, you have continually getting the training credit in order to maintain that professions. And of course, certifications and then licensing for people to be a professional. So if you're interested, there is, in our website, there is that detailed description of each one, every one of them. And we are building up different components. We work on various parts of this component, various of us doing it. So a couple of things I want to highlight on. When we actually trying to figure out with all those components, which one is more important, what would people need to start, we did a survey. And the top three out of all the artifacts that we have here, the top three are body of knowledge, IT body of knowledge. That's the first one. The second one is the standards for the IT core processes. And the third one is the technical standards that you need for IT. So the number in white, 50%, 47, 46, are the result from the employee, the practitioners, people who's working. The orange one or yellow one is response we collected from the executive, from the CIO, from the employer, people who hire people to think what's important. So as you can see, for people who's hiring people, they think IT body of knowledge standards are very important in their mind. So as I said, all the professions started with a body of knowledge. Back in late 90s, we started our first software engineering body of knowledge, and we offer training and certification and certify software engineers online, and we actually have the course and testings in different countries to certify them. We also work on the system engineering body of knowledge. System engineering is very close in many ways as enterprise architectures. As a matter of fact, it's a very strong resemblance. System engineering body of knowledge, we are actually collaborating with 4 or 5 very important institutes around the world to develop this body of knowledge. The latest one that we worked on, it's called Enterprise Information Technology Body of Knowledge, EIT-BOK. And this is the one I want to spend a little more time today, because this is what's relevant. E stands for enterprise. So enterprise IT body of knowledge. It's not just the body of knowledge, but body of knowledge, IT body of knowledge in the enterprise sense. And all these are developed by IEEE Computer Societies. So just so to give you a little bit ideas about the schedule for EIT-BOK, it's a brand new one. We've been working in it for 4 years now. This is our 5th year. Our first release for internal release in the community with our partners and people who collaborate with us is in October of this year. With the version 0.1, it's going to be released to the worldwide, to our partners in Asia, in Europe, in Russia, for their input and comments. Following that, we would have a period of review, and following that, we will have a version 1, a general review, a general release in April 2017. We could move that forward a little bit, depends on how much response we have, and when we're going to have it out to that. One of the difference between our body of knowledge with EIT-BOK is we realizing that it is very important for us to say more than just body of knowledge, but what do you need in your skills and competencies as part of the body of knowledge. So we started working with the different competency framework around the world. One of the most popular one almost around the world is called Skill Framework for Information Age, SOPHIA. SOPHIA is initiated in Europe, in England, and it has 6 categories: strategic and architecture, business change, solution development and implementation, service management, procurement management support, and client interface. So there's 6 categories that it divided. Each category, they're divided into 7 levels. Level meaning that you go from lowest level 1, you follow what people do. Level 2, you assist people to get job done. 3, you apply. You can do it. You can apply yourself. 4, you can actually enable. You can do more than just apply. You can enable. And 5, you can actually teach others. You can advise others how to do things. And if you go to 6, you can actually see the futures. You can initiate things. You can influencing where the directions of the company or the business is. And 7 is the highest level where you will set strategies, you will inspire people, and you will be able to mobilize the whole company. Right? So that's what Sevilla framework is. Again, you can look it up for Sevilla. We are lining up our body of knowledge with the Sevillas. The other one, that notable one, is called European E-Competence Framework, or ECF for short. And in that, that's pretty much all across Europe. They break down to 4 dimensions. Dimension 1 is plan, build, enable. Plan, build, run, enable, and manage from end to end, from start to finish. And they have 40 E-competencies spelled it out, and there are 5 levels that spells it out. And Dimension 4, they give you the real-life examples of the knowledge and skills that actually apply. More importantly, we've been working with IPA in integrating with their ICD. This is where we come in. This is where IPA become a major part of our effort. So in 2015, October, we announced our officially adopt ICD into our EIT BOC, part of our release. And we work with the like of EJ-san and others then you will be talking more today about the specific models. In March of 2016, we had an international workshop with IPA, ACM, and Computer Society in Los Alamitos. We worked it out, all the different issues and details, and to get us all ready for the first release. So in October, we will be released. In our first release, we include the ICD references in our EIT BOC. I want to shift a little bit different now about the future. There's a book called Abelard to Apple. And it's a very interesting book to read. And it's written by this visionary professor from Georgia Tech. And his name is Richard DeMillo. And I like to, the reason I'm thinking it's very interesting is that it looked down the future of university, what is going to be like. Appellate meaning that the old way of teaching in the medieval where you would have an institution, people go to school, people go there, people live there, people have a dorm to live in, people would study in an enclosed environment of education entities. Apple means the world of iTunes, where people access everything online. And this is possible because about 10, 15 years ago, the world is flat. Many of you might have read by Thomas Friedman, about how the world become flat. We can reach each other in an instant now. We don't have to go with a distance. Everything's flat. And that makes it possible for us to be able to educate and learn and certify without being on the same place. What it says is that in about 10, 15 years' time, most graduate university would no longer require you to go and attend universities. You can get your graduate degree through online training, online testing, online certification, online, and you will be able to get a master's degrees or even PhD degrees from certain institutes. So the concept of foreign student working student visa is going to be a thing of the past. You can literally take a degrees in Master of Engineering in MIT, for instance, without having to go attend the MIT. So that is what the future is going to be. The future, the small colleges, the small institutes are going to start to become online presence rather than having people go there and attend. In IEEE, we are leading in the technology. We have a report called 2020, and this report is examining all the different technologies that's in the horizons. Cybersecurity, Internet of Things, which is what we call embedded systems, or data science, or big data. With that in mind, we are developing different training and certification courses that will be recognized around the world for certifying it. So that if you certify for cybersecurity by IEEE Computer Society, it can be recognized from one university to another university for graduate study work. So that is what our goal. And we started working on that on various of these technology areas. How do we do that? The first thing you have to do is, in the past, if you want to pass the exam, you have to come to the exam room. You have to spend 3 hours in the exam room in one location, closed door, and you have a proctor who actually watch everything you do so you don't cheat. What we developed with Carnegie Mellon University is this online proctor, meaning that you can take your exam anywhere in the world. And this setup, it's going to monitor everything you do. And you have no access to anything outside of that computer. And the computer is set up with configured strictly for testing purpose, with the camera monitoring every movement that you do. And if there are any suspicious activities, the exam will shut down and you will fail. So it's now become the more acceptable in the world now. It's now adopted by university in Thailand, university in China are started using these online tools so that they don't have to bring hundreds and thousands of students to one place for the exams and to get their certificate. I like to talk about some of the conferences that we have. And I'd like to bring attention to you, and in the video you saw that, we have rock stars, we have Tech Ignite, we have about 1,000 different types of conferences around the world in various different topics. The reason I'm bringing you the Rockstar event is it's very industry focused. It's a small event. What we do is we pick a very special topic that is relevant to the industry, say cybersecurity, data science, Internet of Things, and we invite 6 to 8 keynote speakers that world famous, almost like a rock star, we call them, of the industries. And they would have a very intimate sessions with the participants. The participants are invitations only. We only invite industries, executive, management people, and some experts to those conferences. And what it provides is for the participants to have a very close network experience with each and every speakers. And it's a one-day event. We limit it to about 200 or 300 participants. And this is very successful in the North America. We just finished one in Singapore back in May, and it was full up to the capacities, and we had a very good feedback on that. What people say about it is we actually trying to get what people need today in the industry, what the professional need in the industries. And we have very like CTO or CIO or CEO of a different company as our speakers that are being recognized. And the topic, like I say, is something that's relevant to the industry that a lot of people are interested in. By the way, the topic for Singapore was cybersecurity. And that proven to be one of the biggest topic around the world today. And what it's going to allow you is going to allow you to have takeaway of what you need to do, the actionable insight. You understand something more, and you got your network. You can connect with the experts, not just with the speakers, but as well as with the participant audience, since they are all top of their field. I want to bring your attention to to the one that we have in China. It's coming up in October. It's in the place called Taiyuan, which is Shanxi. I think it's about 2.5 hours from here. October 19th, we are collaborating with Chinese computer federations on this event. And this is one event, if you are interested, I would be able to have an email address for you to actually make the inquiry, and you will be invited if you are deemed qualified to participate in the event. And we are expecting a very full participation in that. And who knows, in the future, we'll be very interested in having one in Japan, perhaps working with IPA and others to have an event like this in here and bring industry people like you together to have an event and to understand how you can benefit from such an event to be able to solve your problem, the problem you have today, the topic that actually somebody else is working it out, the problems. You can share the solution, you can share others. And I think that is all I have for today. Again, if you want to know more about me, all you have to do is Google Andy Chen Catronic. And in there, you'll have some of the speeches I made in the past. And I think it also has my contact information. And I welcome you all to contact me if you have any follow-up or questions. Or you can also leave the question with the event organizer, IPA, and they'll be more than happy to relay your question to me. And I will be able to respond back to you. For that, thank you very much for your attention.